So, hello everybody. My name is Etienne Juliot. I'm one of the founders of the Obeo company, and I'm also involved in the Eclipse Foundation and one of the board of the director. And today I will present you how we can do team collaboration on the top of model build with Sirius. So first, just a quick review. My talk will not be an introduction about Sirius, but if you don't have any, who knows Sirius already? Okay, so I planned some short slide to just explain the spirit of this tool. Sirius is an open source tool at Eclipse, which provides a framework and the tool to simplify the way you can create your own graphical editors. So basically, you don't have to code your shape, your behavior of your designer. You just have to configure them, and the runtime of Sirius make them happen to the end user in live. So it can rely on any kind of EMF models, and you have a complete freedom of the way you represent your informations. And it works also with plenty of other EMF-based technologies such as Xtext. It's a mature product. It has been created for years, and it's already deployed to do a space shuttle, to do very big IT systems, so in plenty of domains. The process of creating a Sirius-based designer is first to do your own meta models or to rely on an existing one. If you already try EMF, you perhaps already try Ecor Tools. Ecor Tools is a tools based on the top of Sirius, so you already use Sirius as the end user. So after you have defined your concept and your vocabulary with EMF, you have you have to implement your specific editors. On this part, you modify VSM file, viewpoint specification models. So that's just a tree-based editors which help you to do the mapping between your EMF concept, your graphical styling you want to apply to them, and the query to know how you find one element to another one. And you can use SVG image, boxes, edges in the way you want. And also you can have some, how can I say, conditional style or reactive design, so the color change in front of some constraints and some your own rules. Size can change, so it's designed with validation and constraint directly inside your design. You can also add some complementary tools such as MS Word document generations, connector import-export to others, and code generators, comparison between versions. That's all for my introduction about Sirius. And now, one big challenge of using models for persons is to help them to communicate, to help them to work together. And when you want to do graphical designer, sometimes it's to target business persons which don't have skills about using such a tool like Git. And it could be a barrier for them to go inside modeling tools. Or sometimes you want to deploy modeling tools at a large scale, for example, to design an architectures. And you can have plenty of persons simultaneously which want to work together, and it starts to be a nightmare to be able to merge them. So based on this, we introduce the way to do real-time collaborations on your models. To explain this, I created a video I will present you, which explains this principle. So, you imagine on a classical way, you have two users which just use classical file. So you have one version and you have to send your other version to somebody else. And to manage by yourself the collaboration between persons. When you work simultaneously on the same element, you have to have one of the users which have to do the difference and merge. It works. We can use EMF compare tools for this, but it's painful. It's not something easy to do. And so you're wasting time in this approach. It works, again, but it's complex. Another approach is to do fragment. You can split your semantic element or your diagram element in several sub-files and say for each person, he has the responsibility of one fragment. So it's, I will just come back later. So in Sirius, you can do this at the semantic level, at the graphical levels, but you have to think how you want to split your models in several ways. And that's not the most valuable task you have to do when you do this. So what we propose is to use a shared repository which is distributed, so you didn't store your model on your own laptop, but on a server. And to have very simple and fluent ergonomy. For example, here, I modify the name of this guy, and it's locked at the fine gray, just this element. The other user can continue to modify somewhere else in the models. He's not blocked, but he cannot modify the element locked by this one. As soon as one of the two users saves, it's refreshed on the other user, like in Google Docs. So you directly see the modification of the user. You can, so you can imagine that you create some new element that it has been done here. And here, you can, as soon as the other one creates a new person, a new woman, you can use it, associate it inside these ones, and it works. So you can imagine to have something really fluently, without any chance to do something which generates a conflict, because it's pessimist. And that's to explain this behavior to your end user, that's basically 5 minutes of training. Just work as it should be. On the graphical point of view, you can also have some lock systems on the diagram itself. So this time, if I save, it's refresh the diagram itself to see this. So if you modify the diagrams, it will lock the diagram itself, so you cannot move anything when you modify the graphical shape. So I will show you this with a live demo. I prefer live demo. Usually it's better. The process to do this is first to start a server. So I already start one. So here it is. The server could be, it's Equinox based, it's CDO based, so it could be deployed on Linux, Windows, and other. Secondly, you share your existing models to this repository, and after you just collaborate. So let's go. Yep. Here is the first one, and the second one. Okay. Up. Okay, you see? So in this example, I will just, for example, rename Elena to say that her name is Roxanne. I modify. As you can see, I have some green lock. Green lock say that I lock this element. I don't do anything explicit. The tools do it by itself. And it just lock only this element. So the other user can continue to modify and say here, Akos is Mike. It can work. But if it try to modify Elena, the system will say that it has been locked by user 1. So I cannot modify anything. I'm not allowed to modify anything. So here, if I save, you will see that automatically it has been refreshed and the lock has been released. And here for Akos, I can release this. Oops. Here it is. Oops, sorry. If here, this time, I modify the graphical shape, you will see that the lock is not on the element itself, but it is on the diagrams. You can see that the lock here is on the tabs. It means that here, I cannot modify anymore. The palette has been blocked. I cannot move anything. But if I want, I can modify the semantic. But it will not refresh the diagrams. Do this. I save. And it's live updated there. Last example here, I will just say that Mike is the son of Paul. Yeah. You see that the lock this time is on Paul. There are several elements which has been locked because it detects that doing this kind of edge modify the target and the source. So it's locked several elements. And if I save, it's automatically refreshed there. It works also with this kind of element. Oops. Alan. And it works in property sheet too. Okay. So basically, you have perhaps see 80% of the features. So it's quite simple. If some user want to explicitly lock some element, they can select element and say, I want to lock this element before doing any modification, or I want to lock the element and all the containment of this element. So if you want to, to have the ability to modify without anybody which block you, it's modified in the same way. As soon as you close your Eclipse, it will release the lock. And you have also the ability to do long-term lock, which survive to the close of your workbenches. And so we have administrative feature to release this if the guy died during the night and you don't want to keep the lock. Any question?
Can you easily see who has a lock?
Yep, good questions. So here I will modify Alan again. Okay, I go there and see that it is locked by user 1. And if I modify here, Fiona, oops, I can see that it is a guy named Juliot. I know. Let's do this. And no. When you, I will show. Okay, I will show you how can I connect to a server. Okay. So first, when I launch the server, I can launch the server with memory database, which will just crash at the end of the server with a classical database. That's the normal way, with authentication or not. The authentication could be plain text or could be an LDAP Active Directory authentications. When I will remove. Yep. Okay. Here, I start from scratch. I want to create a new chair modeling project. I connect my element. That's a wrong port. Because I have plenty of demos, so I change the port. I hope that's a good one. Yep. So it asked me my name. Okay, it works. So you can do SSL connections if you want. And after, I have all the repository available on my server, so I have only one. And here is the name of the local project. When I launch, it just proposes me all the viewpoints, so that's all the set of diagrams I want to open. And that's all. And when I work, it's like everything is on my computer. So it's the same look and feel, the same ergonomy that classical Sirius user. But under the hood, the file here, it's just it's empty. It's just a reference to the server. Okay. So if I have some tools like code generators, like connectors, they just don't see that it is a collaborative model. They just work with EMF. It's completely transparent.
The locking capabilities are CDO features. It's not related to Sirius.
Yeah, but what I present you today is proposed in the tool called Obeo Designer Team. So that's a commercial tool on the top of Sirius and CDO. So everything is stored in a CDO repository. There are some API in CDO, but all this strategy of locking systems is something which is specific to Obeo Designer Team. You don't have this behavior per default with CDO. Okay?
And to show these annotations and everything.
Yeah.
That's
Yeah.
obvious.
So, yeah, about the business models, we think that open source is a good way to do innovations. And I spend plenty of time to think where is the limit, where I should put the bill, to be able to have a viable business model. And we choose this because it's fair for the user. There isn't any vendor locking. You can import, export at any point. You don't miss anything on your diagram configurations. You don't lose any data. And it's target team, which need to be several persons together on a real project. So for small, for independent, for very small team, you can just work for free as usual. And it's target mainly for projects which could have funding to pay this kind of stuff. So I think it's fair in a business, open source business model point of view, and it's fair about the community because I'm very clear that it is not freely available. So that's something which is important for me to know who are the boundaries of something open source. Okay? So I will show you, I close because I have 9 instances of Eclipse, so I don't want to crash my laptop. Because I will show you this decline on other use cases. One will be for model-based system engineering, another one with enterprise architectures, and in these two use cases, there are some customization of the lock strategy, of the look and feel for the end user. But before this, so here is a very short overview of the architecture. So we already discussed about this. So if you know CDO, it's based on this. We are involved in the CDO project. We work also with Ike Stepper to do some improvement in CDO, to fix some bugs, to be able to work on large models, to scale and to have good performance. Yep. So what I saw as the user feedback of this feature is that several users can really work simultaneously. So it's completely changed the workflow of usage of modeling tools. So sometimes they go in meeting rooms, they put one laptop on the screens, and they all work together on their laptop simultaneously on this. So that's something which was completely different to co-working sessions. You have some data access right too, to allow read and write for some part of the models. So it's useful. We don't lose time lost for managing configs. I heard some person which say that they previously, they lost between 1 and 2 days to every 2 weeks of work by dealing with conflict. So it's really depends on the skill of the user, but it starts to be a huge break in their productivity. And it's still standard data exploitations. So if you want to try after my talk, there is a community edition, which is the 100% of EPL bundle to start to discover Sirius. And there is another edition with this team add-ons, which is available. And about the business models, we propose this as an add-on to contract, a fixed price contract or support and maintenance on Sirius and other relative technology. So we do this in a way that it's not based on the time consumed for support, because by propose something which is at a fixed price, the better the documentation is, the less you will cost, the less bugs we will have, the more revenue and the more benefit we will have. So that's something which is a virtuous cycle. And it provides the same guarantee than traditional software editors. So that's something which is quite relevant. So first use cases, it's with Capella. Capella is an open source project at Eclipse to do model-based system engineering. So it's built on top of Sirius. It has been creating with several decades of experience of senior system engineering at Thales, and it aims to do the specification and the architecture of a product in a better way than just doing several thousand of text requirements, which will just be a nightmare to master what you want to do. And so the goal is to define what is the expectation of the systems, what is all the external element of your systems, and how you want to design in a black box and after in a white box your systems, the input, the constraint of cost, the constraint of performance, safety, and so on. The big difference with other tools on this is that it provides a methodology. And the tools is methodology oriented. So it means that you know where to start. You have some small designers focus on one activity, and you can easily go step by step in your design to translate some high-level requirements to a physical design. And when you do this, you can have some engineers with different skills. For example, here you will have mainly the manager, and here some technical guy. And so you need collaborations, which is quite important. And the goal of this also is to avoid person which works sometimes on Excel files, some other on Word files, some other with a dedicated tool, but having a place where everybody collaborates on the same architecture, the same architecture definitions, and the same specifications. So let's try a demo there. Okay. So I already launched a server, and I have my 2 users. Yep. Okay. So here you have the 2 same diagrams on the right and on the left. And this time I will go inside this activity. So just to explain what you see. You see here, for example, the different actors which are responsible of video system when you go in an aircraft. Okay? And you see that there is a passenger, the crew, and you define what are the activity of each of them, and you just allocate the expected activity. Okay, I will go to listen to audio activity and drill down inside this. and see that, oops, inside it, Listen to Audio have some link with other activities. Okay, and I want to have a more detailed. Oops, sorry, not this one. More detailed view of the same element. So if I modify here Listen to Audio to say that Listen to Audio and music, it will do a lock as it has been done previously. But this time, if I save, it's forced me to add the descriptions, to have a traceability of each commit I do to the server. So I like music. It's commit, and this time also, they didn't want to use automatic refresh. They want to have explicit refresh. So I cannot modify my diagrams here because something occurs on the models which need to be refreshed. But we ask the user to, by hand, update it. They want to have this process to be sure that they control everything, but also in terms of performance, because these use cases go with very, very large models sometimes. They do this to be sure that the tools could have some good performance each time, everywhere. Okay, so I have my element, I think, somewhere, yeah, which has been updated. And of course, I can have several views on the same element, as you can see. Any questions? So, about performance, I can show you some example of large models. This one, for example, or this one. Yeah. And as you can see, it starts to be quite huge. And under the hood, there are plenty of different elements. So it's usually every collaboration on this work with less than 1 second. So it goes quite fast. But our advice is generally to have a server on the LAN to have a good lag, to avoid a ping which could take 1 second just by the network transfer. So, how they deploy this? So, our advice on this is to use the collaborative server as a collaborative server, not as a long-term repository. So, the workflow usually is to have your classical repository, your Git system, a repository, a PLM, I don't know, everything you want. And so it's quite simple to integrate this in an existing workflow of usage. So you have your first versions, and at this point say, okay, I want to have a whole team to work together on the same element. So I export my model and all my diagrams on the collaborative server, and at this point, everybody works on this place. You can do manual or automatic Jenkins export in your SCM to have some versioning there, or if you want to publish the result to other teams, or to use it as an archive way, you can do this. So there are some features which help to do this and to keep traceability of all of these modifications. After a sprint of collaboration, which could be 1 week, 1 month, 1 year, you say, okay, I finished this, I release my new versions, and I kill my collaborative server. You can continue to do some evolution there, perhaps with 1 person, 2 person. You don't need any strong collaboration, so you continue as usual. And one time you can say, okay, it's come back, I have plenty of new needs, and I recreate a new server with these new versions. So that's the spirit of this way of collaboration that we propose. Okay. Second use cases. I will close my Eclipse. Oops. No. Oh, sorry. Okay. I think and I will launch this one. Okay, so this other use cases, the second use cases is for what I call enterprise refactoring. It's for the enterprise architects, the persons which needs to have an overview of your enterprise, the organization chart, who is responsible of what in your enterprise, the process, which process is deployed on which applications, which application communicate which other applications, how is it deployed on the infrastructures. So you have an overview, kind of cartography of your systems, and it's useful to do impact analysis if you want to modernize a new framework, a new application, a new infrastructure. You know who will be impacted by this. If you want to modify a process, you know what are the IT software you have to update things to this. So that's something which is very, very useful and ready to use for architects. And I will go directly to the example. So we rely on ArchiMate. ArchiMate is a standard made by the Open Group, which, for example, helps you to use color code to see that here there is Red Hat, which is used by an LDAP server and by a virtual machine there, which deploy in blue your applications, and your applications is managed by the marketing department or by the sales department. So you have this kind of view of your systems. To do this, we target manager, CEO, director, architects, which don't have we don't know how to use Eclipse. So we create web front end, which diffuse all the diagrams you do on a web browser, and it's connected on the collaborative server. So as soon as you modify anything on your collaborative element, it will publish on the web automatically. So let's try to open one. Here I am on the web part. Okay, so I have a classical web ergonomic. I can search, I can do plenty of things. And this time I have the edit button. If I edit this, it launches a classical Sirius-based editor, but you don't have all the workspace or everything, which could be too complex for this kind of persons. So I can add something else to say that there is an actor here, Etienne, and this actor is at Nantes. Yep. Okay. If I save, as soon as I save, the Smarty product refresh everything which is on the web. So basically, they collaborate with us using this URL, put it in an email, in a wiki, anywhere, and each time there is a modification on the server, it is refreshed, so always up to date. This time, this usage of the collaborative server is as a real repository, long-term repository. So the goal is so it's a different strategy of packaging, different strategy of persistent to be able to provide this for years in the enterprise, and to be administratively configurable as any classical server. just show you a second example. Here is it. Okay. Yep, any question?
Is this web-based?
No, not at all. That's so here I open a rich UI. As you can see, it's not really a browser, but if I go to my Firefox somewhere, where is it? Okay, so don't care. If I go to Firefox, I will have exactly the same look and feel, the same ergonomic, except one thing, that you don't have the edit button. So what we do here is that when you launch this executable, we just open the SWT browser component full screen. So the user usually thinks he is launching something similar to a browser, and under the hood, we just intercept the event of the edit button to open something which is a native Eclipse-based editor. So for the long term, of course, we would like to have everything on the web with a new front end, but that's something which have to be a long-term investment, and that's a step we find which is quite convenient to go in these directions. And as Sirius has already a standalone engine, which could be used on the backend without any UI, and which don't have any dependency to SWT, GAF, and other, we can reuse this to go to these directions. Other question?
Another question is the CDO choice. There are some other EMF persistence frameworks like EMF Store or
Yep.
CDO.
Yep.
Why did you choose CDO?
For several reasons. First one is that when we did the choice, and currently still today, we think that's the more mature project. So we want really to have a high level of guarantees on performance and scalability, and our comparison say that CDO is the best. Secondly, for the lock systems and the collaborations, it also gives the best experience. CDO, and I'm not sure about EMF Store, are mainly focused on storage the element and not so much on the collaboration itself. So that's also a second reason.
Is it possible to link your smart EA tool to
Iteraplan?
Yes.
Oh yeah. So this tool has been built in logical of creating plenty of connectors. You know, when you design this kind of cartography with all your technology, virtual machine node, if you have to recreate from each time by hand all your VM, it's just painful. So we have an architecture where you can plug your own connectors to other tools like CMDB, like Iteraplan perhaps, and other, to try to just concentrate in the same place some elements which come from other. So it's up to date. It's updating every night with Jenkins jobs, and you can have several data sources which are merged together. Okay, and on this use case of Smarty, it's bundled with ArchiMate, but we can also use your own meta models and your own designer on these platforms. So that's the second use cases of this, and it's bring branching future and this web portal experience. I think I'm over our time. Thank you, everybody. And just go to me if you want to have some other element, or if you want to have some trial version to play with it, it will be with pleasure. Thank you.